Have you ever wondered what's really going on behind the scenes when you hear the term AI? We're constantly bombarded with it on social media, in the news, even at the dinner table. It's often painted as this magical, mysterious force that's changing our world. But here's the truth. AI isn't magic. It's engineering. It's built on very real systems, software, and a whole lot of human ingenuity. Before we can even start talking about intelligent algorithms and futuristic models, we need to get one thing straight. AI doesn't exist in a vacuum. It doesn't just float around in the digital ether. Every single AI system, from the one recommending your next favorite song to the complex models used in medical research, runs on a solid foundation of hardware, operating systems, networks, and software platforms. Without this foundation, AI is just an idea. It simply cannot function. So let's break it down. At its core, what is artificial intelligence? It's all about processing massive amounts of data and making decisions based on the patterns it finds. Think of it as a super-powered apprentice. You give it tons of examples, it learns from them, and then it applies that learning to new situations. This entire process collecting data, processing it, training a model, and then deploying that model relies entirely on modern computing infrastructure. Let's start with the muscle, the hardware. AI systems are incredibly hungry for computational power. They depend heavily on powerful hardware like CPUs, which are the brains of any computer, and GPUs, which are specialized processors originally designed for graphics but are perfect for the parallel calculations needed in AI. And now, we even have specialized accelerators like TPUs, designed specifically for AI tasks. These components are the heavy lifters, handling the billions of calculations required to train complex models and run them in real time. But having a powerful engine isn't enough. You need a driver. That's where operating systems come in. The OS, like Linux or Windows Server, manages all the computer's resources. It juggles memory, allocates processing time, and makes sure all the different parts of the system are working together efficiently so that AI workloads can run smoothly without crashing. It's the unsung hero that keeps everything in order. On top of this hardware and OS layer, we have software frameworks. If you've dabbled in AI, you've probably heard names like TensorFlow and PyTorch. These are like toolkits for AI engineers. They provide pre-built components and libraries that make it much easier to design, build, and train AI models. Instead of starting from scratch every time, engineers can use these frameworks to speed up development and focus on the unique parts of their problem. And let's not forget the cloud platforms like AWS, Google Cloud, and Azure. These services provide the infrastructure, tools, and scalability needed to deploy AI on a global scale. In fact, most real-world AI systems you interact with are running inside these massive cloud data centers. They often use Linux-based servers and something called container technologies, like Docker and Kubernetes, which package up the AI application and all its dependencies so it can run reliably anywhere. Now let's talk about the fuel for our AI engine: data. This is arguably the most critical part of the entire system. An AI model is only as good as the data it's trained on. This is where data pipelines come into play. A data pipeline is the journey that data takes from its raw form to being ready for an AI model. It involves collecting data from various sources, cleaning it to remove errors and inconsistencies, validating it to make sure it's accurate, and storing it in a way that's easy to access. And this isn't a one-time thing. For many AI systems, this data needs to be continuously updated to keep the model relevant. This is why AI engineering is so closely tied to back-end systems, databases, and distributed computing. Without high-quality, well-managed data, even the most sophisticated AI algorithm will fail. Garbage in, garbage out. So you see, creating an AI model is just one piece of a much larger puzzle. In a real company, building a successful AI product involves so much more. There's monitoring to make sure the system is performing as expected. There's security to protect the data and the model from threats. There's performance optimization to make the system run faster and more efficiently. And there's a huge focus on system reliability to ensure the service is always available to users. This is a team sport. AI engineers work side by side with software engineers who build the applications, DevOps teams who manage the infrastructure, and system architects who design the overall structure. It's all about keeping the system stable, scalable, and secure. Today, artificial intelligence is making a real impact, transforming industries from healthcare, where it helps diagnose diseases, to finance, where it detects fraud. It's changing transportation with self-driving technology, and even helping us write better code in software development. But behind every one of these revolutionary AI products, there's a story of solid engineering, careful design, and the practical, real-world constraints of building and maintaining complex systems. The intelligence part gets all the headlines, but the artificial part is where the true work happens. It's built piece by engineers solving concrete problems. To wrap it all up, AI isn't some standalone magical entity. It is the culmination of decades of progress in software engineering, system design, data management, and computer infrastructure. It's a powerful tool, but it's a tool that is deeply integrated into the technology stack that powers our digital world. So the next time you hear about a groundbreaking AI, remember the invisible army of engineers and the complex systems working tirelessly behind the curtain. Understanding how AI really works means looking beneath the surface and appreciating the incredible engineering that makes it all possible. If you found this deep dive into the engineering behind AI helpful, show some love by hitting that like button and let me know your thoughts in the comments below. What part of the AI stack surprised you the most? And don't forget to subscribe and turn on notifications for more content that demystifies technology. Thanks for watching, and I'll see you in the next one.